Welcome to graphing sine and cosine. So now today we're going to graph the function y equals 2 plus 3 sine 4x plus pi. And this one has everything. First thing you're going to do though before we begin is make a 6 by 6 table. And let's label the table x and then period, phase, because we always deal with the period first and then the phase, y, and then amplitude is kind of stuck in there in my graph, and vertical shift. And then let's go through all of our steps. So the first step is to factor out b. Now we'll need to write this step down because finally we have a b to factor out. All right, so b here is 4. Let's factor that 4 out. All right, so if we factor out the 4, we'll have y equals 2 plus 3 sine. The 4 comes out. So 4x divided by 4 is x. Pi divided by 4 is pi fourths. And now we have our equation with the b factored out. It'll be a lot easier to identify the phase shift and the period once the b is factored out. So next, let's identify the amplitude. All right, so thank you for identifying the amplitude for me. That pause was so you could answer. And now let's identify, let's have you check your work. I'm going to identify the amplitude right now. So the amplitude is the coefficient in front of sine. So the amplitude is 3. So if you said 3, you were correct. The period. So now I want you to identify the period. All right, so now let's identify the period. All right, so remember to find the period, you take 2 pi, divide by b. We know b is 4. So that's going to be 2 pi divided by 4, or pi halves. Let me move this up a little bit. So if you said pi halves, you got it. All right, now I want to identify the phase shift. All right, so now the phase shift is what's added to x. All right, so it's right in the parentheses there. If you have no parentheses, you have no phase shift. Remember that there's a negative in the equation, so it's x minus c. So if we see a plus, it's really minus a negative. So the phase shift, I'm going to have to write it over here, is pi fourths to the left, or negative pi fourths, either way you like to think of it. And finally, identify the vertical shift. All right, so the vertical shift is what's added to the whole function. We see 2 plus the sine function. So that means the vertical shift it's positive, so it's going to be up 2. And that means the midline is y equals 2. I think we've seen that one before. So now we've finished step 1, we finished step 2. Now let's take on step 3, identify the 5 key points. I guess I'll write in red. The 0 and the pi halves is stuck there. And so always our x values are 0, pi halves, pi, 3 pi halves, and 2 pi. The y values that go with that, right? So sine starts at 0, then goes to 1, 0, -1, 0. Right? And we've done that on the unit circle. Right? So 0 corresponds to the x-axis, 1 corresponds to the positive y-axis, 0 corresponds to the negative x-axis, -1 corresponds to the negative y-axis, and 0 is back to the x-axis. But remember, sine uses the y value. So on the x-axis, y is 0. On the positive y-axis, sine is 1. On the negative y, part of the y-axis, sine is -1. Right? So now we need to adjust everything. So we have our x and our y. We actually aren't going to use the x again because we have a period change. Right? So for period, we take the period, and we divide by 4 to find the new values. I can't even fit dividing by 4 here. But dividing by 4 is the same as multiplying by a fourth. So let's just do that. All right, so that's going to be pi eighths. So that means we're going to start at 0 and count by pi eighths. So 0, pi eighths, 2 pi eighths, which we could reduce to pi fourths, 3 pi eighths, and 4 pi eighths. Squeeze it in there, which we can reduce to pi halves. Notice that that matches our period. The period is pi halves. The last value under the period, under the column marked period, is pi halves. So that's exactly right. Now we need to add, or in this case subtract, our phase shift because it goes to the left. All right, so our final thing is to subtract the values of the phase shift from the period. Not our final thing, but the final thing for x. So we're moving pi fourths to the left, so we're going to subtract pi fourths. 0 minus pi fourths is negative pi fourths. Pi eighths minus pi fourths. Well, pi eighths is the same, pi fourths, excuse me, is the same as 2 pi eighths. All right, so pi eighths minus 2 pi eighths is going to be a negative pi eighth. So notice these are going to keep increasing by pi eighths, right? Because we're going up by pi eighths on the period. Pi fourths minus pi fourths, well, that'll just be 0. 3 pi fourths minus pi fourths is going to, wait, what am I, oh, excuse me, yeah, pi fourths. And, oh, wait a second, that's not 3 pi fourths. I got thrown off by counting by changing the 2 pi eighths to pi fourths. It's 3 pi eighths. Oh, that is an eighth. I just can't read my own handwriting. Here, let me write that nicer. I looked at that and thought that was a 4. Well, I don't think I can get it in there, but that's an 8. Maybe you can read my handwriting better. So 3 pi eighths minus pi fourths, that's the same as 2 pi eighths. I knew it didn't make any sense being 3 pi fourths. It didn't fit at all with the rest of the values. So 3 pi eighths minus, boy, that's messy. I'll just rewrite it. Minus 2 pi eighths is the same as pi eighths. And then finally pi halves minus pi fourths, so a half minus a fourth is pi fourths. All right, so there's our phase shift value. So those are going to be the x values we graph by. Now, so we've taken care of this step 4 and step 5. Step 6, we're going to multiply the y values by the amplitude. The amplitude is 3, so we're just going to multiply everything by 3. So this is easier. The phase shift was a little tricky because we had fractions. We had to change the denominator. Is going to like denominator, but this is pretty easy. So 0 times 3 is 0. 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3, and 0 times 3 is 0. So done that. Now we just need to add the vertical shift, and that will be pretty easy as well. We're just adding 2, and so that's not very difficult. So the hardest thing was adding in the phase shift, and it usually is the hardest thing. So we have 2, 5, I hope this fits, 2, negative 1, and 2. All right, so I will have to go off the graph a little bit. And you'll have the exact same problem. So just extend your graph. There we go. Just in the y direction. Now we have some mighty small values. It would make sense to label our values so they go up by pi eighths. So let's label every other line pi fourths. So for instance, this would be negative pi fourths. This would be 0. This would be pi fourths. This would be pi halves. And this would be 3 pi fourths. And this would be pi. All right, so now we have values that make sense with our graph, and we're not giving ourselves a super skinny graph and making it difficult for us. All right, and our values are going to be ones that are on the line, because the ones I didn't number are 8s. All right, so each line is an 8th. So now our points that we're going to graph, and I'll write them down just to make sure that's clear. Negative pi 4ths 2. All right, so negative pi 4ths 2. Oh, I didn't label the y's. Negative 1, negative 2, 1, 2, 3, 4, 5. All right, so negative pi 4ths 2 is right here. Oh, one last thing. We forgot to graph the midline. Silly me. All right, now we've got everything. What made me think of it is because, of course, our old x-intercept will now be right on the midline. So now we're ready to graph. We've got our graph labeled. We've got our midline graphed. And now let's graph our points. So negative pi 4ths 2. Our next point is negative pi 8ths 5. All right, so that's going to be way up here. Our next point is 0, 2. Our next point is negative 3, negative 1. Oh, excuse me, I'm looking at the wrong value. Pi 8ths, negative 1. I can't tell how I'm writing because my podium is creating a shadow, so I have no idea what my writing looks like. I hope it's legible. I'm sorry if it's not. So pi 8ths, negative 1 is right here. Wait a second. That just seems really low. No, that's right. Okay. That's right, because our amplitude is 3, right? So we're going to go up by 3 times as much. And then the last point is pi 4ths 2. And I don't know where I'm writing this, so hopefully it's legible. It'll be a surprise when I look at it on the tape. Now let's connect our points. All right, so we have up and down and up. Right, and then our graph is just going to keep doing the same thing over and over again, forever and ever and ever. And our last step is the domain, -infinity to infinity, and the range, you can see from our graph, the low value is negative 1, the high value is 5, it's oscillating between those values, and we use brackets because the graph does go between those points. And that's it. The next graph will have all 4 transformations, but it'll be cosine. Thanks for watching. Bye for now.